Hi, I'm Lauren Paulson, and today I want to share with you the charged tape experiment we did in Physics 2. To start this lab, we need tape. We then need to measure out two 8-inch pieces of tape. We then need to fold down the tape so there's a handle and press one of the pieces of tape down to a desk. We then need to press the second piece of tape onto the first piece. We then need to rip these two pieces of tape apart. Now this piece of tape should be charged. As you see, it's attracted to my hand. Now we need to create a second piece of charged tape. When we bring these two pieces of tape together, we can see they repel each other, meaning they have equal charge signs, so either they're both positively charged or they're both negatively charged. We can also see the piece of tape is attracted to a neutrally charged item like the table. This is due to, despite the table being neutral, the molecules in the table will polarize so that the charged tape is attracted to it. Next, we want to figure out the charge on the tape. To do this, we can put it next to an item we know the charge of. We know that if you rub a pen against your hair, the charge of it will be negative. So if the tape is attracted, it will be positive. As we saw earlier, the two pieces of tape repel each other. This force can be enough to even overcome gravity and cause one piece of tape to start to float. These are the physics principles used in this lab and the equations we will use going forward. After the lab, I used GlowScript to calculate the charge on the tape and model the forces on the tape. Momentum on the floating piece of tape remains constant. This means there's a constant velocity and zero acceleration, and therefore also no net force on this piece of tape. Despite there being no net force on the tape, there is still the force of gravity acting on it, as well as an electric force due to the other charged piece of tape. These two forces drawn out look like this, very similar to our GlowScript model. In order to determine the gravitational force on the piece of floating tape, we need to find out the mass. This is because the force is given by F equals ma, and we know A is equal to little g, or 9.8 meters per second squared. So we have to find the mass. The mass can be given by using that fact that the tape is 1 gram per meter and my tape was 20 centimeters long. Using these to calculate it, we get that my tape would have been 0.2 grams. We can also assume that each piece of tape had the same net charge as they were charged in the exact same way. To find the amount of charge on the floating piece of tape, we will first be ignoring air resistant, treating both pieces of tape as point charges, and assuming that each piece of tape has the same amount of charge and that charge is evenly distributed among us. First, we need to calculate the gravitational force on it, and then we will set that gravitational force equal to the electric force, leaving one variable of Q, which is the charge on it, which we need to solve. And once we solve that equation, we will get Q is equal to 9.33 times 10 to the negative 9th coulombs. We can use this information to calculate how many electrons are in a deficit on the tape by just taking in our charge and dividing it by the amount of charge in an electron. This gives us 5.833 times 10 to the 10th electrons we are missing. We can use the amount of electrons in deficit to get the number of atoms to the ratio of number of electrons in deficits. To get this, we get the atom size. I did this by assuming the atoms were square. Then we can get the tape's area. Then we can divide this to get the number of atoms in the tape, and then just taking the amount of electrons and dividing that by the number of atoms, we can get the ratio of number of electrons in deficit to the number of atoms. If electrons had a positive charge and protons had a negative charge, what would change about the observations we made? Well, the tapes would still repel each other, as they would still have equal charges of the same side. Also, every item the tape was originally attracted to, so it would have been a negative item, the tape would now repel, as now the tape is negative. Also, every object the tape was repelled by, which means it would have been positive, it would now be attracted to because it is now negative. This is only talking about charged objects, though. It would still be attracted to any neutral objects, though. This is because these neutral objects would still polarize to attract a charged object. When doing my experiment, I tried to touch the tapes as little as possible. Why was this? This is because if something hits the tape can actually pick up electrons from that object, making it no longer charged and potentially neutral. This would mess up this experiment, as the entire point of this experiment is to work with a charged item. Thank you for watching. I hope you enjoyed my video.